Hello everyone, thank you all for being here for this webinar. Today I will be talking about our Geobody interpretation capabilities and the new features that we're bringing to Geobody interpretation in the 2019.3 version, which is our most recent release. We introduced Geobodies and Geobody interpretation to GVERSE Geophysics in the 2019.2 version that came out last year. We define Geobodies as areas in your data that have similar seismic characteristics, and since 2019.2 you have been able to isolate these areas and pick them and save them as a new interpretation object called a Geobody. In today's session, I will show you how to pick Geobodies on your data and then go over some of the new features that we are introducing with 2019.3 and that we hope will make Geobodies much more useful in your interpretations. There are a couple of ways you can pick these Geobodies. It can be a completely manual process where you go to a section, mark an area that you want to include in your Geobody, and then onto the next section, and so on. Once you have all these seeds, you can then interpolate them to get your three-dimensional Geobody. You can do it manually, or you can track a signature automatically. For automatic tracking, you simply indicate one or more starting points, define an amplitude threshold. All samples in your volume that meet the criteria, this amplitude threshold that you've defined, and are connected to your initial seeds are then saved to your Geobody. So for this webinar, I'm going to pick a couple of Geobodies using both the automatic and manual picking methods, and then show you some of the tools that we have to use these Geobodies in your interpretation workflows. I have an inline number 100 displayed here. You can see this anomaly pretty clearly, this amplitude anomaly pretty clearly here. I've picked this Geobody for a webinar before for a few demos that I've done. So some of you might already be familiar with this particular Geobody that I'm going to pick right now. It shows up really nicely on my average energy volume. So I'm going to switch this inline to average energy. So now I'm looking at the same inline from the average energy volume, and this bright blue area, this region, is what I'm interested in picking. So that's my Geobody, but that's the Geobody that I want to pick. If I render this as a volume, I can visualize this structure before I even pick it to see how big it is, how far it extends into my volume. So even before I pick my Geobody, I can get an idea of what the body should look like when it's picked. I can do that in a separate 3D view. I already have a probe added here. This is a probe from the average energy volume, so I can see data. Probe is basically just a cube with data displayed on all 6 sides. And that right now I'm looking at this probe from the average energy cube, and that there's that same event, that same feature that I want to pick as a Geobody. Now, if I render this as a volume by pushing this button up here, click yes, that's going to take data from the average energy cube and stuff it into this probe. And now it's got data, filled up this little room, this little box that I have on the screen. And then I can play with the transparencies of these colors to make parts of this probe, this volume, transparent, so I can actually see through it. To do that, I can just move my mouse along this histogram on this bottom left part of your screen. This green line that I've drawn, all the amplitudes that fall along this green line, they're rendered transparent. So I've tweaked my color palette to make all of these range of values transparent. All I'm left with are these high average energy values. These are the ones that are left as opaque. And a result of that is that I can actually see inside my volume to see how that structure sort of extends into the volume and what it looks like, or what my Geobody should look like once I do pick it. I can pick the Geobody right here on this view, so I can just mark these seeds right here, hit the tracking button, and that's going to track this Geobody as well. But I'm going to do that on the inline, so let's switch back here to this feature that we want to pick on. Now, to pick a Geobody, the first thing you have to do, of course, is to create a Geobody. Do that from the Geobodies ribbon up here. Go to the Quick Add option. Give the name for your Geobody. I'm going to call it G1. Give it a color. Let's just give it a little red color. Hit Create, and that's going to create the Geobody and set it as your active Geobody. The active Geobody is the one that's going to get all your seed picks. So you have to, if you're picking multiple Geobodies, you have to make sure you have the correct one activated, so your seed picks actually go into the Geobody you want them to go to. The active Geobody is indicated here in this drop down. Also, bottom left of your status bar of your window, you can also see the name and the color of the active Geobody right here. To mark your seeds, we have two different modes that you can use. The polygon pick mode, where you isolate the area that you want to use as your seed with a polygon. You enclose it in a polygon, and that's taken as your seed picks. Or you can paint over it using a brush, what we call a brush mode. So just click on the brush and just paint on the area that you want to mark as your seed picks. You can afford to be a little sloppy, because as you'll see in a moment, we can actually define the amplitudes that we want to keep, and that applies to seed picks as well. So you can afford to be a little sloppy when you're making your seed picks. Make sure you get everything you want to include in your Geobody. Hit the generate button. That's going to give you this histogram, which is the data distribution of your seed picks. So everything that fell under those seed picks, under this region that I've just painted, the data distribution, the distribution of the amplitudes for those seed picks is given here. Now, I'm interested in just picking a very high average energy areas. I don't want the low average energy areas, so I can then take this maximum slider and push it all the way to the end. That's going to ensure that all the high average energy values in the volume are included in my Geobody. Now, because I was a little sloppy when I was making my seed picks, I have to adjust this minimum slider so that I exclude those values, those low average energy values that might have slipped into my seeds. So I can adjust this minimum slider to get that value. Now, the amplitude threshold that I've defined now falls, of course, between these two lines. So it's going to take any amplitude that falls between this min and max as a valid amplitude to add to your Geobody. The other thing that this algorithm looks for when it's tracking the Geobody is the extents. You can set your extents if you want your Geobody to be limited within a certain region. You can set those extents right here from the left-hand side of this little dialog. You can do it for the entire 3D survey, which is my setting right now. You can point to a probe that you have set up. So we have this one probe in 3D View 2. So if you want to use the extents of that probe, you can do that. You can do a customized setting, of course. Provide a hard range here in terms of inlines, crosslines, or a fixed time window. 2019.3 also introduces the ability to make this time window variable by specifying two horizons that you can use as the top and base of your time window instead of having a fixed time interval there. So let's try that out. I'm going to set the top horizon as FS8, which is this red horizon going right through here. The base horizon, I'm going to use this orange horizon, FS7, that's going through here. So I'm going to, now when I generate my Geobody, samples that fall above or below these two horizons that I have selected here are not going to be included in my Geobody, even if they're seed picks. So these seed picks that I have here are not going to be included in my Geobody. Once I have all of this set up, I hit the generate button. Now it's going to take all the samples that fall within my extents, check the amplitude threshold. Do they meet the amplitude criteria? If they do, they're going to be added to my Geobody, and then the system is going to check all the neighboring samples for that one sample that was added to the Geobody. If those samples meet these criteria as well, they're going to be added to the Geobody. Move on to the next sample, the neighboring samples for that sample that was added, and so on until you find a sample in the Geobody which has neighbors, none of which meet the amplitude threshold that we've defined, and that's when the Geobody tracking will stop. So I have my Geobody right here, and you can see how it looks very similar to what we had in the volume that I just showed you. I can actually copy this over to that volume to compare these. So let's copy it over to 3D View 2, and you can see there's the pink Geobody is the one that we have tracked. The blue is the signature that we were trying to look at. Of course, we didn't get the whole vertical thing because we limited our tracking between the two horizons, so you didn't get the whole thing vertically. And you might also notice that this second part of the Geobody seems to be connected, but we haven't picked that. There could be two possible reasons for it. Number one, the connection between here, maybe the amplitude threshold that we defined, this connection might have fell outside that threshold. But most likely what happened here is that this connection fell above the top horizon that we had. So because these values were out of the extents of the Geobody that we were trying to track, they were not picked up. If I were tracking on a fuller extent, these most likely would have been part of the Geobody as well. So that is how you track a Geobody. We also have a manual method to pick your Geobodies. This is where I will make picks on different sections in my volume and then interpolate those picks to get a Geobody. This is useful to have in certain situations. Channels are a good example of that. So let's do that and pick a channel as a geobody. I put a time slice from the semblance volume in this third 3D view. You can see that channel going right through here. Channels, of course, show up really nicely on horizontal slices on semblance data, and I have this channel going right through here. If I want to pick that as a geobody, along different time slices, I can interpolate to then get a look at what this channel actually looks like in 3D. To pick it, the first step, of course, is the same. I have to first create a new geobody. I'm going to call it channel. Let's make it yellow. Hit create. I was going to create that geobody. Make sure it's the active geobody so that the pics actually go into this active geobody. I'm going to use the brush mode, make the thickness a little thinner, and then just follow this channel along on this time slice. And there's the second channel going through here as well, so I'm going to pick that as well. And that's the two channels here. Now I can navigate to the next section. In 2019.3, we've also moved this navigation bar down here as part of your scene. It's no longer in the ribbon. It's semi-transparent, so when your mouse is off of it, it doesn't really get into your way. You can control the amount of transparency you want it to be using the preferences. When you bring your mouse back over, it sort of turns into this opaque bar. The reason for this is, make navigation a lot easier, quicker. So if you have your scene on a separate screen, you can still use this bar. You don't have to go switch back and forth between the ribbon to get to just to navigate your seismic section. So this navigation bar that we moved here, I'm just going to move up 10 milliseconds. There's my section. There's my channel going right through here. So I'm just going to pick that part. Let's undo that. I made a bit of a mistake here, so I'm going to pick that right here. This is the second channel feature going right through here. Let's do another one. There's my channel. There's the second part of that same channel. I think I'm going to do one more. And let's just pick that here. And this. So I've marked my seed picks. But when you're interpolating, you have to be more careful. You cannot be as sloppy as you were during your automatic picking, because these picks are going to be used as is. When you interpolate, we're going to take these picks as they are and just interpolate through to connect them into a geobody. The generation process is very similar. Go to the generate option. Now, I can't really use the tracking option here because semblance data, as you can see on this data distribution histogram, the semblance data, because my seed picks cover both the low semblance areas and the high semblance areas, the amplitude threshold that I need is so big that it's going to try to pick the entire volume, resulting in a useless geobody that I don't really need, and probably one that's so big that the system will actually stop before it even completes the whole tracking. So it's going to say, this geobody is too big, I'm not going to pick it anymore. So that's where the interpolation method is actually useful. Just switch to the interpolate method right from over here. If you want to set the extents, but that's not really very useful in this case because you're going to be interpolating between your picks, not really tracking, so extents don't really matter much in this case. Hit generate, and that's going to take your picks and it's going to generate and interpolate them into this channel system that you're going to see here. If I hide this time slice, that's my channel system that you can see now, picked manually and then interpolated to show you your channel as a geobody. Now 2019.3 also brings the ability to actually edit your seed picks once you've made them. You're no longer required to delete any bad picks that you had. So for example, this channel, I did not do a good job of picking it. If I want to edit this, I just go to my edit seed option. That's going to take my active geobody and it's going to try to edit that. If I zoom in, you can see that these little dots show you, you can move them around. So they are the track, they're the seeds. They track the seeds that I make. And as soon as you change one of them, try to change one of them, you get this error message, a warning message that's asking you, because as soon as you change them, the geobody surface that you've created is going to be invalidated. So it's just making sure that you want to actually go in and change it and it's not a mistake. Say yes to that, and it's going to, now you can go ahead and change these. You can add nodes, remove nodes. You can even remove this entire stroke. If you don't like this one stroke, you remove it and you just add it again. So I'm going to go here and add that stroke. You can also change the width or the size of the brush by just using the slider in the edit mode as well. So a lot of functions available for you to be able to generate or edit the seed picks that you've already made. Once you've made your changes, hit the generate option again, choose the interpolate option, click generate, and that's going to now create the updated Geobody surface with those updated seeds included in that Geobody. So that's my channel system picked as the Geobody, displayed in the 3D view, which is sort of giving you an overview of how that channel is progressing both in the X and Y direction, and of course the thickness, how that's varying across your seismic survey. So our last release, 2019.2, introduced these Geobodies, and this is how we can pick them using tracking or interpolation. But Geobodies in 19.2 were limited to mostly a visual analysis, except for being able to use the velocity model or a constant velocity to estimate the volume of the Geobody. There wasn't really much beyond a visual analysis of your Geobodies that you could do. Well, that changes with 19.3, this new release. We are adding a few things that we hope will help incorporate Geobodies in your seismic data interpretations in a more meaningful way. The first of these, and in my mind at least the most important feature that we've added, is the ability to map your Geobodies. So if you've picked your Geobody, let's take this channel for example, and now you want to see how the thickness varies along this Geobody. You can of course eyeball it in the 3D view, that'll give you the big picture. But if you want a more quantifiable result or observe the more subtle variations in the thickness, you would want to look at on a map with colors representing the thickness along this channel feature. Well, that's easy enough to do now. Just select the channel, this Geobody in your scene, right click on it, say copy to, or even move to a new map view. That's going to add a new map view to the interface, and now you can see this channel mapped on a map of this channel on your map view with the colors representing the thickness of this channel. Let's turn on the color bar right here. So you can see the reds represent the thicker parts of this channel. This part of the channel is thickening right here. This one sort of thickens right here as well. So that's a map of your channel displayed on your map view. There are a few types of data that you can display here from the scene tree. Click on this drop down to view the list of available options. You can do a time structure map of your channel, of the top surface of your Geobody. So if I click this top option, this is now giving me a time structure map of how the top of this channel system sort of varies. You can see that this one is as we go towards the south, it sort of deepens pretty gradually, both these channel systems. You can also look at the structure map for your base of your channel. That seems to be much steeper in this case, the reds being your deeper values, of course. You can do the gross thickness. That's the default option also. That's the top of the Geobody subtracted from the base of the Geobody. So your top surface and base surface subtracted gives you the gross thickness. But if your Geobody has vertical fingers-like features in it, where there are vertically overlapping fingers which have parts of which are not in the Geobody, that can show up in the net thickness. For my channel, of course, since there are no vertical fingers, the gross thickness and net thickness look pretty much the same. But if there were vertical fingers in this feature, they would the gross thickness and the net thickness would be different. The net thickness being not just a simple subtraction of the base and the top, but we figure out the thickness of each finger of the Geobody, and then add those thicknesses up to get the gross thickness. So that's the different kinds of data that we can map for a Geobody, its thickness and the top and the base surfaces. 2019.3 will also let you create layers out of these maps to take them to GeoAtlas or GeoModeling and other GeoGraphix apps. So if you want to use the Geobody in a volumetric equation that you've set up in GeoAtlas, just create a layer of the thickness, and that's going to be then available in GeoAtlas. All you have to do is make sure the correct data is being displayed on your map. Right click it, say create isomap layer. That's going to bring up this dialog box that's going to create the Geobody for the gross thickness surface. That's the one that was displayed here. Just say finish. That's going to create that surface that layer, and then that's going to be available in GeoAtlas. When you create a layer from the map view, whatever surface is displayed, whatever attribute here you've selected, the top surface, base surface, gross thickness, net thickness, whatever you've selected, that's the layer that's created. You can also do this from the 3D view. So if you go to the 3D view, right click here and say create isomap layer. The 3D view lets you choose which surface you want to, map you want to create the layer for. So you can do it for the top of your Geobody surface, the base Geobody surface, or either of the thicknesses. You can also access this option from the Geobodies ribbon. Go to the create layer option in the operations group, and you can choose which map you want to create your layer for. And once you have your layer, it is then of course available in your GeoAtlas map or all other GeoGraphix applications where you can use them in any workflow that you need that layer for. So you can now create time structure maps for the top and base of your Geobody along with maps for your thicknesses and save those as layers. You can also take the top and base surface of the Geobody and convert it into a horizon that you can modify just like a regular horizon, or do horizon math on, or use it in your velocity models, or whatever use case you might want the top and the base of your Geobody as horizon surfaces for. Again, a quick process. From the operations group, you have the convert to horizon option. Click on that, brings up a very small little dialog box that asks which of the surfaces you want to convert. So if you want to convert the top surface, check that on. If you also want to convert the base surface, check that on. Give it a name. If you don't like the underscore top and underscore base, you can change those. Hit convert, and that's going to take the top surface of your Geobody and the base surface of Geobody and create two horizons for that. Add them to your interpretation, and there they are, channel top, channel base. If I add them to my scene, that's my top horizon, that's my base horizon. From the 3D view, I'm going to hide my Geobody so you can see the top horizon and the base horizon for that channel. So I'm closing that channel pretty completely, so you can hide one of them. So just see the top here, hide the top, just see the base. So you can now take your Geobody, take the top surface, take the base surface, and convert it into your horizon. So that's a couple of useful features right there. Another feature that I think a lot of you might find useful is that we've updated the attribute and surface calculator to include Geobodies. You can now calculate attributes within the Geobody. Bring up the attribute and surface calculator. That's on my other screens. Let me just bring that window on here. The attribute and surface calculator now lets you define the analysis window as a Geobody. That's my two Geobodies, G1, which was that bright spot that I was trying to pick automatically through automatic tracking channel, which I picked manually, and we've been creating maps and layers for. You can choose the Geobody. That's going to be the window, your analysis window. You can select whatever attributes that you want to create on that. Choose your data, hit calculate. That's going to create attribute surfaces for those two attributes that I selected for the Geobody. That was my Geobody G1, and you can now see that attribute surface. 2019.3 also lets you view these attribute surfaces in a 3D environment. So that's a enhancement that we've added to our 3D viewer, is the ability to view these 3D surfaces on in your 3D view along with your map view. So you can see this new node called attribute surfaces, which any attributes that you create are going to be shown here. Just add them to the scene using the plus icon, and that's my attribute surface for the Geobody that I had, the Geobody G1 displayed here. You can see the data distribution for that as well. This is the peak amplitude, average peak amplitude within that Geobody. Now, by default, when you add the attribute surface to the scene, it shows up at the top of the Geobody that it was created for. But you can change that. Go right here to your display settings. This display setting for your surface, your attribute surface, lets you choose the display at option, which is by default, like I said, set to top surface, but you can go to the bottom surface as well. This is the base of my Geobody. I can show it as a flat layer at any time on my survey. So if I want to look at it 500 milliseconds, I can just punch that value in here, and that's going to show it to me as a flat layer in my 3D scene. I can also drape it on any horizon surface that I choose. So if I want to drape it on the FS8 horizon, I can do that right here. Now, if you created attribute surface for a geobody, these are the options you get. If you'd created the attribute surface between two horizon surfaces, or about a horizon, or between two time slices, these display options will change accordingly. But the constant time option and this last horizon, specific horizon option, they're always going to be there. These two options depend on the window used to create the attribute surfaces. So you can now also look at these attribute surfaces that you create. One of the most important outputs of any seismic interpretation are these attribute maps. You can now view them in the 3D viewer as well. Apart from that, we've always had the ability to do a simple volume calculation for your geobody. That is accessed from the volumetric option. Of course, since I am in a time interpretation, I will need to provide some sort of a velocity value to compute my volume. If I was in a depth interpretation, this velocity option will not be available, of course, because I don't need that velocity. I'm already in depth. But in a time interpretation, I need to convert that time axis to depth, so I need some sort of velocity value. You can either use the velocity model, or if you know a representative velocity already, you don't suspect too many variations, lateral variations in the velocity values, you can type in a representative value, let's say 2500 meters per second. Hit calculate. That's going to calculate a volume in cubic meters for this interpretation, because my units are set to metric. For you folks in the US, you mostly work in the in feet, and so if whatever display settings you have for your interpretation, that's what's going to be used here. Since I'm in meters, my velocity is also in meters. I get my volume in cubic meters. We also maintain a log, so you can try different values here without having to keep a separate notepad or an Excel file with all the values that you're trying. These values are saved with the interpretation, so that you have access to them whenever you open a specific interpretation. If the geobody changes since the last time you made these calculations, you get a little warning message warning you that these values may not be relevant anymore, since you've changed the seed picks or regenerated the geobody, so these values may not be relevant anymore. One last thing that we've added is the ability to take these geobodies and view them in the depth mode of a time interpretation. The depth mode is where we take the 3D scene, including all the seismic sections and horizons and faults, and convert the entire time scene to depth using your active velocity model. Geobodies were excluded from the depth mode in past versions, but now when you switch on the depth mode, your geobody will be converted to depth, and you can view that on your sections. Let me show you an example of that. So let's go back here to this first scene that we picked, this geobody. I can go in here and from the 3D view, turn on my depth mode. The depth mode is going to take my seismic sections, my horizons, all the data that I have, including now my geobodies, and convert that to depth. Let me switch this to the active version, so you can get a better idea of what the seismic is doing as far as the depth is concerned. So that's my depth seismic, and you can see now the geobody has also been converted into depth, and I can view that in my depth scene as well. We force it into intersection mode, and that's why you don't see the entire geobody surface here. We do that because we are converting the entire scene to depth, and if you have a lot of horizons and geobodies and all that stuff, converting each object to depth will require too much time, and you can't really do that in a reasonably small amount of time anymore. And the utility of this, having this one switch that'll take your entire scene and switch it to depth, becomes a little questionable. So we force it into the intersection mode. That way we can still show you what the geobody is doing relative to the depth seismic without having to spend that time to convert that. In future releases, you will be able to convert the intersected view to a full geobody, to a full horizon surface in case of horizons, fault surface in case of faults. That way, when you choose to view the surface, it will be on demand, which will obviously be less expensive computationally, and so you will, in the next release, be able to view the geobody surface in the depth view, in the virtual depth mode of time interpretations. So that's an overview of our Geobody interpretation and some of the new features that we've added to make Geobodies more useful in your interpretations. We're working hard to add even more useful features to the Geobody aspect of our application, along with so many other areas. I do want to say that a lot of these features that you see here today are a direct result of user requests that we received. So I urge you to please get in touch if there's something that you think might be useful, and hopefully we'll be able to get that into the software for everyone to use. You guys should be getting a replay email a little bit later. That's going to have my contact information in there. So please feel free to reach out if you have any sort of feedback. Thank you very much for being a part of this presentation today.